Hello, in this video we're going to look at more features of functions and what they mean. So the first feature of a function we're going to consider is a positive and a negative feature. And all that means is that on certain intervals the function is either positive, which means that the y-coordinates are positive or above the x-axis. And one way we can note that is saying f of x is greater than 0. Versus we say a function is negative when the coordinates are below the x-axis or where f of x is less than 0. So I'm going to color coordinate where on the graph those two things are taking. Now when determining the intervals where the function is positive or negative, you always want to start on the left side of the graph, and this first part of the graph is below the x-axis, so it is negative. So that would be my first interval where the function is negative. Then the next section is positive. And then again, the next section is negative, and I'm going to finish color coordinating. One important thing to keep in mind is that at the x-intercepts, the function is neither positive or negative because f of x is equal to 0 at those points. So, as you can see from the colors on the graph, there are 3 sections that are negative and 2 sections that are positive. So let's write these down. One important thing to remember is with the positive and negative feature, we already know what the y values are doing. We know that they're either greater than 0 or less than 0. Therefore, when we write our intervals of positive or negative, we will use only the x values to describe the intervals. So this first interval that's positive starts at -3. So right here it starts at -3 and it ends at -1. Now, notice I'm using this in interval notation, but I'm only using the x values. And since it's not positive at the x-intercept, it's not equal to positive there, so I'm going to use parentheses. We never use brackets with positive and negative since it's never equal to at the x-intercepts. Then we have another interval where it's positive, and that interval starts at 1 and it ends at 4. And again, just parentheses. Remember to use the x values and always have it in the format left x, comma, right x. Now, you also need to denote that both of those intervals are positive, and the way we use this interval and another interval is by using the U shape. The U is union and just represents and. Now, there are 3 intervals where the function is negative, so I'm going to have 2 unions, so I can have 3 intervals where the function is negative. So the first interval starts all the way to the left and goes all the way up to -3, so I would say it's from -infinity to -3. Then the next interval is from -1 to 1. And then the last interval is from 4, and it keeps on going to the right. So that's going to be infinity, not -infinity, because I'm only writing my x values. The next feature of a function we're going to look at are extremas. And there's 4 types of extremas: absolute maximum, absolute minimum, relative maximum, and relative minimum. So an absolute maximum would be an absolute highest point on the graph. And as we can see in this graph, this would be our absolute highest point. There's nothing higher, the point 2.9 and 4.8. So that's all we have to write. The next extrema is an absolute minimum point, and that's just the absolutely lowest point on the graph. And when we look at this graph, we see that there's arrows pointing down, which just means there's no absolute lowest point on the graph. A relative maximum would just be a maximum on a particular section of the graph, but not the overall highest point. So it's kind of like looking for a peak of a mountain without looking for the absolute highest peak. So as you can see, negative 2.2 and 1.9 is a maximum, but not the most highest point. So therefore, it's just a relative maximum. And you can have many relative maximums, but you can only have one absolute maximum. Same thing with relative minimum, but it's the lowest point in a section of the graph. And even though we don't have an absolute minimum point, we do have a relative minimum point at 0, negative 1.2. The last features of a function we're going to look at in this video are increasing and decreasing. The definition for an increasing for a function is, as the x values are increasing, the y values are increasing. While the decreasing definition is, as the x values are increasing, the y values are decreasing. So as you can see, both definitions are looking for as the x values are increasing. So that means we're reading our graph from left to right, and we're just trying to determine if the graph is going up or down. So let's look at the graph. As I said, I'm going to look as the x values are increasing. So I'm going to start to the left, and this is how my x values are increasing in this direction. And if you look at the hand I have here, for this first section, my graph is going up, therefore it is increasing. Then if you look at the next part, my hand is going down, therefore it is decreasing. Now, one important thing to note at this point, which was our relative maximum, the graph is neither increasing nor decreasing because it's just shifting between the two. So let's write these first two intervals. This first interval of increasing starts all the way to the left and it doesn't really stop, so it would start at negative infinity and it would go all the way up to this x value. The reason we're going to use the x values is because we already know what the y values are doing. They're going up, but we want to know for what part of the graph they're going up. So for which x values are they going up? So we would say the first interval of increasing is from negative infinity to negative 2.224. Notice I used a parentheses around the point because negative 2.224 is not included because it's neither increasing or decreasing at that point. The next interval on the graph was decreasing, so the next part of the graph, so starting at negative 2.224 and all the way down to the next x value, which is 0, the graph is decreasing. And again, I'm not including 0 because at that point it is switching back to an increasing part of the graph. And lastly, we'll have one more section where it is going down, therefore it's decreasing. So let's write those two intervals as well. So the next level of increase is from 0, which is just continuing where this was decreasing, all the way to this x value, which is 2.935. And to show that both of those intervals are increasing, I have to put the U symbol for union, which means and. Same thing with the decreasing features. We have two parts that are decreasing, so I'm going to use the U symbol and write the second part where the graph is decreasing. And the second part is decreasing where it stopped increasing, which was at 2.935, and it keeps increasing all the way to the right, which is positive infinity for the x value. That's it. Using a sketch of these graphs, try to answer the following questions. What are the x-intercepts for this function? Since these are points, make sure you put commas between them to indicate there are multiple points. These are not going to use u's like intervals. Where is the function positive? Notice I am using u's to show that there are multiple intervals. Where is the function negative? Where is the function increasing? And lastly, where is the function decreasing?